Okay, good morning, everybody. Hope you guys are doing well today. Today, we are going to start into our last chapter and section before we take another quiz. And that chapter and section is chapter one, section 7. And there's a couple things we're going to cover in here. So, we're going to determine whether a relation is a function, and then we are going to find function values. And so I would say out of everything that we've done out of these, this is the third and final section before we take another quiz. Finding the function values is it can be the trickiest one, I would say, out of all the objectives that we're covering right now. So let's start with the first objective, though, which is to determine whether a relation is a function. So first thing I want you to look at is this picture that we have here. This picture is of a just a random machine. Maybe it's something you'd see in Dr. Seuss, for instance. But what this machine does is we put things into the machine, and you can see the inputs or the independent variables, as we talked about in the last section. And those are the x's. And those x's get put into this machine, and when they come out as outputs over here. And the outputs usually are different numbers than what was put in. But the machine that accomplishes this is called the function, and that's this. That's this part right here, this function. And so the function is made up of different math operations, possibly numbers, that change the numbers that we put in to give us new numbers out. And so that machine is going to be called a function. So the first thing we're going to look at is vocabulary. So this is what the definition of a function is, and it says a blank in which each element of the domain is paired with exactly one element of the range. And the word that goes in there is called relation. So in general, if you have a bunch of ordered pairs, those form a relation. Now, they may or may not be a function, and I'm going to go through what actually qualifies a relation to become a function. But there's some set rules that have to be followed in order to be considered a function. A relation is any set of ordered pairs that you have. So let's look at this first example they have right here. They show you a domain and a range, and you can see every value in the domain is paired over to a value in the range. And so if that happens, that is a function. That's a mapping, by the way. You should remember that. Now, I'll show you an example of when it would not be a function. When a mapping fails to be a function is when you have one x and it might split like this. You see how that -3 goes to the 5 and the 2? That's not allowed in a function. So that would cause that not to be a function. Now, if you look at this graph right here, this squiggly graph, this would be considered a function as well. And it has to do with something called the horizontal line test, which we will talk about in a second. So looking at number one, you can see that we have a mapping. And as I showed you over here, or in the last part, a mapping fails to be a function when an x value goes to more than one y value. Now, if you look here, it's okay that this x goes to 6 and this x goes to 6. That's okay if they both go to the same number. What is not okay is if one x splits and goes to two y's. So looking at what we have here, each x is paired with a y, and an x doesn't get paired with two different y's. So the first question, is this a function? You would write, yes, this is a function. Remember, it's when we have more than one x, more than one of the same x. So if -2 goes to -3 and -2 goes to 6, that's when it's not allowed to be. Looking at part B, if you were to write the mapping out from the first one and you had this say no, the x would be listed twice. So we're looking for x's that are being listed twice. If an x is used and listed more than twice, it is not going to be a function. So looking down at part B, we have x is 1, we have x is 3, we have x is 5, and then we have x is 1. So as you can see, right here x is 1, right here is x is 1. And if I drew a mapping, what you would see is that number 1 would be split and it would go to the number 4 and -4. That is not allowed. So this is no, it is not a function. Moving over into part C, same thing here. We look at our domain, which are our x values. So we're going to look right here in this, and we're going to look for any x values that are listed more than once. And so if we go through, we have a -7, and then we have a -4, and then we have a 2, and then we have a 5. So all of those x values are good because there's nothing repeated. So because the x value is not being repeated, yes, this is a function. Now in the last part of this, part D, you can see we have x is 2, x is 3, x is 4, and uh-oh, x is 2 again. So you can see we have a 2 there and a 2 there. So again, if I would draw a mapping of that, if I had the 2 over here, it would split and it would go to 1 and -2. That is not allowed. You cannot split an x. You can't have an x listed twice. So in this case, the answer would be no. This relation is not a function. So hopefully what you saw in all four of those examples is you can't have a repeated x. And that's really the only thing we're looking for. Now there's something called the vertical line test. So when I set up here, this graph right here, um, I can see that it's a function, and it has to do with a test that we call a vertical line test. And the vertical line test is very simple. The vertical line test tells us that if you pass a vertical line anywhere through a graph and it hits the graph more than once, then it will not be a function. So if I give you an idea of this first one, if I put a vertical line here, it's only intersecting the graph in one place. If I put one here, only intersecting the graph in one place. One right here, only intersecting the graph in one place. Now, as a side note, the axes don't count. It's just the actual U-shaped. So anywhere that I put a vertical line there, it is only intersecting the graph in one place. Therefore, that is a function. The answer is yes, this is a function. Now, if you look at the next one in the middle, if I put a vertical line through right there, you can see I'm intersecting the graph right there and right there. So if I intersect the graph in more than one place, the answer is no, not a function. Okay. Now the last one is a little tricky because if you put a vertical line right there, you can see, all right, doesn't intersect anywhere, right? If I put a vertical line right here, doesn't intersect anywhere. But if I put a vertical line right down through here, you might say, oh, look, there's a point right there and there's a point right there. But what you have to do is key in on the fact that this one is a solid one, the bottom point's a solid, whereas the upper point is open. So the open one doesn't count. Now, if the top one was solid, then it would count, but it's not, it's open. So no matter where I put a vertical line in this third one, it actually doesn't intersect the graph in more than one place at a time. So the answer is yes, this is a function. And that's called the vertical line test. And so we're going to try these next four, and then we'll be all done for this video. So the first one says, is this relation a function? And if you want, you can go through and draw a bunch of vertical lines, but you can see every time I draw one, it only intersects the graph in one place. So the answer is yes, this is a function. Now F is a circle. You can see as soon as I draw a line through there, it's intersecting the graph in more than one place. So the answer would be no. G, same thing. You can see that's actually a sideways parabola. If I draw a line down through there, intersects right there and right there, it's intersecting in more than one place. So the answer is no. And so this last one is very tricky. So I'm going to zoom in a little bit on this one so we can see this a little closer. You're always looking to see if there's any points that line up. Now, if you notice right there, that's an open dot and a closed dot. So if I put a line through there, the open dot, that's all right. That's still good. Anywhere on this upside down U-shaped, we're good. There's another closed and open dot right there, but again, one's open, so we're good. and there's still another closed and open dot there, and one of them is open, so that's okay. So this one would actually be yes, because it passes the vertical line test. So that's that, guys. You're all set. That's the graph, and yes, that would be a function. And that's all I got for you today. So have a good day. We'll talk to you soon.